So a quick refresher in long division. What I'm going to do here is I'm going to take these two numbers and I'm going to set them up. 8 is the number that I'm dividing, so that goes underneath the long division bar. And then 6 is the number I'm dividing by, so that's the thing that goes outside. So now I ask myself, how many times does 6 go into 8? Well, it goes in there one whole time. Now I multiply 6 times 1, and then I subtract. 8 minus 6 is 2. Now I start over. I ask myself, how many times does 6 go into 2? Well, 6 doesn't go into 2, so that means that this 2 here is a remainder. The way we're going to write remainders, we're not going to write R2. We're going to take that remainder, which is 2, and we're going to write it over what we divided by, which was 6. Now, 2 over 6 is a fraction that reduces. So my final answer would be 1, and then 2 over 6 reduces to 1/3. So if I divide 8 by 6, it goes in 1 1/3 times. All right, now number 2, I'm going to take 25. I'm going to take 500 and I'm going to divide it by 25. All right, so the first thing I want to know is how many times does 25 go into 50? So I'm not looking at the whole 500, I'm just looking at 50. So if I take 25 and I multiply it 2 times, that gives me exactly 50. So I'm going to write 50 here and I'm going to subtract. So 50 cancels itself out. Now I'm going to bring down this extra 0. And I want to know how many times does 25 go into 0? Well, it goes in there 0 times, which is 0. And then I'm going to subtract. So this all seems kind of weird, but it does work out that 25 goes into 520 times. So what that means is that if I took 25 and I multiplied it times 20, it would give me exactly 500. Another way you could think of it, which we're going to talk about in a little bit, is 25 is a factor of 500. So what that means is if I had to do a factor tree with 500, I could break it into 25 times 20. They're both factors of 500. All right, last one, number 3. If I divided 13 by 5, 5 goes into 13 2 times. 5 times 2 is 10. I'm going to subtract them away, and I get 3. There's nothing else to bring down, and 5 doesn't go into 3 anymore, so I'm done. So my fraction, my remainder, would be 3 over 5, and since it doesn't reduce, that's my final answer, 2 3/5. So it is possible to do long division with polynomials. This way will work all the time, whereas what I'm going to show you next is called synthetic division. It does not work all the time. So long division is something you will not have to use in advanced algebra, but if you take a class beyond advanced algebra, if you go to a college class, it is possible that you will have to use long division. So in advanced algebra, you're safe, you can do synthetic division, but I just want you to be aware that this is not, synthetic division doesn't work all the time. So here's how long division works. I'll show you one example. We're going to take x squared plus 5x plus 6, and we're going to divide it by x plus 1. So the first thing I'm going to do is ask, what do I have to multiply x by so that it equals x squared? And the answer is x. So I'm going to line my answer up over the like terms. Now I multiply. X times x is x squared. 1 times x is 1x. And now I subtract. So I change both of these signs to negative. X squared minus x squared cancels out, which is what we wanted. 5x minus 1x is 4x. Now I bring down my next number. So now I'm going to do 4x plus 6. Now I start over. What do I have to multiply x by to make it 4x? And the answer is 4, positive 4 specifically. So I'm going to put plus 4. Now I'm going to multiply. X times 4 is 4x. 1 times 4 is 4. Now I change all the signs, so they both turn into negatives. 4x minus 4x cancels out, which is what we wanted. 6 minus 4 is 2. Now, since I don't have an x with my 2, that means I'm done because I can't multiply x by something and have the x disappear. So this is my remainder. And the way that we write remainders is it's positive, so I'm going to write plus 2, and then I put it over what we divided by, which was x plus 1. So my final answer here is x plus 4 plus 2 over x plus 1. All right, so here's how synthetic division is going to work. In this first section up here, this little spot right here, that's where the 0 goes. So what you're going to do is take this binomial, and if you set it equal to 0 and solve it, that number is what goes here. So I'm going to put a -1 here. Now, in the next section, we're going to put all of our coefficients. Coefficients are numbers that are in front of the variables. So I'm going to take a 1, a 5, and a 6, and those go here. And it's very important, by the way, that you're not skipping over anything. So you have to make sure that your that your variables don't skip over any exponents. Otherwise, you have to put a 0 in there to hold its spot. So now the next thing we're going to do is follow a pattern. So the first thing you're always going to do is drop down your first number. Now we're going to multiply the blue -1 times the orange 1. That gives us -1. That goes in the middle bar. Now you add. So 5 plus -1 is 4. Now you multiply with the -1 again, which gives you -4, and then you add down, which gives you 2. So once you drop down that first number, you multiply, add until you run out of numbers. This last number, that 2 there, that is your remainder. And a fun fact is that this number will also represent your zeros, or your x-intercept, if it's a solution. So that number will always, it's not your solution. It's what you would get if you plugged that root into your equation. So let me write this down. So if you plug that 0 into the polynomial, the remainder is what you would get as your answer. Also, another way that I actually prefer to look at it is if you go to the table in your calculator and you find the 0, so you found -1 on your table, the ordered pair -1, 2 would be there. So the -1 comes from here, and then the 2 would be your remainder. So if your number was actually a 0, you would see that at that 0, like the -1, you would actually have the number 0 as your y value. All right, so these examples are actually going to go pretty fast. The only tricky thing you have to be careful about is that you don't leave out any missing exponents. So I actually like to draw my synthetic division a little differently than I showed you on the page before. So the first thing I'm going to do is take the opposite number of this, so -3, and then I'm going to look at my original problem. I don't see any missing exponents because it goes 3, 2, 1, 0. So I'm going to just put in all my coefficients, 3, -2, -23, and 14. I'm going to drop down the 3, and now I'm going to multiply and add until I run out of numbers. -3 times 3 is -9. If I add down, I get -11. -3 times a -11 is 33. If I add down, I get 10. And then -3 times 10 is -30. And if I add down, I get -16. So since I have a number here, that means I have a remainder. When you write your answer, it's always going to be 1 degree less than the original problem that you started with. So my final answer here, since I started with x cubed, I'm going to start with x squared. So 3x squared, and then I'm just going to work my way down, minus 11x plus 10 with no x, and then my remainder, minus 16, goes over what we originally divided by, which is x plus 3. So this right here is my final answer. For example 2, this one is a little bit tricky because it is missing an exponent. You'll see here it goes from 3 to 1 to 0. So that means I need to add in an x squared. I'm going to add in a 0 specifically for x squared. So I'm going to have positive 2 on the outside, and then I will have a 1, 0, and actually I'll write that in red because that's the one I'm adding in to hold the spot of the missing term, -6 and 4. So I'm going to bring down the 1. 2 times 1 is 2. Add down. 2 times 2 is 4. add down. 2 times negative 2 is negative 4, and then I add down. So you'll see here I got a 0. That means that this one does not have a remainder. What that means is that it divides evenly. So my final answer here, since I started with x cubed, I'm going to start with x squared. So it's 1x squared, but you don't have to write the 1, plus 2x minus 2 with no x, and I don't have a remainder. So what this one means over here is if I took the thing I divided by, x minus 2, and I multiplied it by the answer, 2x minus 2, I would get the thing that we originally started with, which was x cubed minus 6x plus 4. Okay? All right, last one. So I'm going to set up my bar here. I am missing a bunch of terms. It goes 5, 3, 2, 0. So I'm missing x to the 4th, and I'm also missing x to the 1st. So I have to make sure I put in zeros where I have a missing term. So I'm going to have 2, and then I have my missing x to the 4th, negative 3, positive 5. I'm missing x to the 1st, and then negative 1. So now here we go. Oops, I didn't put my positive 1 on the outside. So I'm going to drop down 2, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. All right, so this one does have a remainder, which is 3. My final answer, since I started with x to the 5th, my answer starts with x to the 4th, and then I just work my way down. So this would be x cubed, x squared, x, no x, plus my remainder of 3 over what we originally divided by, which is x minus 1. So that whole big thing is my final answer.